I would like to present design for additive manufacturing. The cost of additive manufactured parts are directly linked to the amount of material that is used. So in order to be successful with additive manufacturing, you need to design very optimal, efficient and lightweight parts. This means that the backbone of having success with design for additive manufacturing is to master simulation-driven design. On top of that, there are some extra benefits to be had, namely accelerated design innovation, or complexity for free as it's come to be known as, the ability to reduce supply chain cost, and lastly, the possibility of simplifying systems. Complexity for free means that at a certain cost threshold where additive becomes viable, extra complexity has no impact on cost. But designing these complexity is not a straightforward proposition, and the ability to do so depends heavily on your skill in simulation-driven design. Here are some examples. SpaceX Super Draco rocket engine, heat exchangers, prosthetics with porous material for better bone adhesion, all components that could not have been designed without the use of simulation-driven methodology. One can achieve significant supply chain cost reduction by consolidating large assemblies into single parts, as shown here in an example from General Electric. By consolidating this mid-frame structure into a single part, they achieved a weight reduction of 4.5 kilograms. They reduced engineers needed to support production from 60 to 8, sub-suppliers involved from 50 to 1, and data systems needed from 40 to 1. The supply chain cost reduction far outweighs any effort to increase efficiency in manufacturing of the original system. We're also able to simplify systems. A system of fewer parts have less risk of failure due to the reduction in connection between components. This increases robustness and means that safety factors can be reduced. And this again means we can design an even more efficient system. I want to end this presentation by discussing how simulation-driven design and design for additive manufacturing can have an impact on sustainability. I have now been talking about these new methodologies and how we can design lighter and higher performing products. But I realize many of you may not be working in product performance-oriented businesses. You might see weight saving as an unnecessary added cost. So let me tell you why, from a sustainability point of view, saving weight should be the focus for everyone. Remember this one? By saving this minuscule amount of weight, we were able to save a whopping 0.74 million tons of CO2 emission. That equates to 186 million tons of CO2 for the combined fleet of aircrafts. There are over 25,000 aircrafts in service as of 2022. Over 38,000 aircrafts are projected to be in service by 2032. So I invite you now to join me for a thought experiment. Imagine if we were able to reduce the weight of everything produced in 2024 by 1%. And I think you can agree that 1% is not some unachievable number. On the contrary, then what could be the impact? Here are some numbers to give you an indication. 1% is 18 million tons of steel, 0.63 million tons of aluminium, or 3.67 million tons of plastic. Mind-blowing. So just imagine what could happen if we think big. Thank you.